How are images useful in a complex project? First, we'll review some images used in a project development environment and discuss their usage. Second, we'll discuss some good practices for structuring Microsoft Project Gantt plans for complex projects. Then we'll discuss getting task date data from project into Excel to be associated with equipment plans for allocation, build, and integration for functional use. Finally, we'll cover how to set up Visio to create the kind of images shown and how to actually build the images in Visio. The object of PowerOpI is to build and manage plans with automation to integrate among detailed operational plans through build and integration plans and into derived images with capability to portray a visual summary of any plan level. People think using their left brain. Quantitative plan details instruct on materials, builds, and integration with quantities, dates, locations, suppliers, all the artifacts detailing execution level work. But people act on their right brain understanding, and visualization is a major driver of behavior. The premise of Power Operational Intelligence, PowerOpI, is that detail-level planning for people executing the plan is directly connected to business-level effects important to executives across all functions of the company. The tools described in this channel provide automation to make those connections, so that is going to drive the left brain understanding. Then we need to create images for right brain understanding of the program at all levels of work, from full detail up to high-level summary. PowerOpI can produce images that are automatically directly connected and representative of the plan detail. The images help program management and project participants to visualize, plan, and track all aspects of the plan. Directly connected summaries help communicate direction and status with senior management and are needed also for formal project approvals and associated documents. Finally, the images visualize effects of change, helping to plan and communicate the changes. The net effect of PowerOpI images connected to detailed execution plans is to build confidence across the project team and across senior management that the plan is understood and rational, and how it fits versus its objectives currently and into the future. These are examples of visualization of development sequences of several major project elements for predicting and tracking engineering progress. The two images at left show electronic assembly fab, build, and test sequences. The top image shows parallelism among development of several assemblies and show an interdependency on a development resource. The image visualizes potentially critical effect on availability, providing opportunity to mitigate. The image at right shows mechanical assemblies developed using a different lifecycle practice for build and evaluation. In this image, the development plan appears straightforward. The image illustrates a critical item at top right, availability of hard tooling for production. This item is carefully tracked as development progresses. These images are successful to cross-check plan correctness and to collaborate on plans among mechanical and electronic engineering, supply chain, and operations. These are backed up automatically by detailed pivot plans with quantity and dates for execution steps. The key delivery milestones shown here also show up in integration plans that we will look at shortly. These images visualize a couple of levels of integration: chassis with firmware, diags, and software, and system level, including integrated chassis with server-level application software. The figure at left shows details of element availability plus integration steps for a series of build phases. The figure at right has proven to be a best practice. A timeline is shown for each assembly element in the integration, showing milestones for availability into integrations. Then integration steps are shown as bars at the top for chassis and systems based on incremental build steps. Key platform test iterations that gate builds are also shown. Development plans for all elements are tweaked to line up elements to be available for the integrations, shown by the vertical lines. This image provides successful visualization for the program manager building the plan to get it correct and to cross-check and collaborate among all organization functions involved. All of this is automatically backed up by rev-level pivot table plans for supply chain, ops, integration, firmware, and software teams. The image visualizes long-term progress toward FCS as well as short-term execution. The image at left visualizes how key software features map into a sequence of major feature block releases, shown as blue bars just below image center. The first feature block, FB1, replicates function from pre-existing product that must move forward to this new product. The second feature block, FB2, implements new function dependent on new hardware capabilities in this new product. The third feature block, FB3, is to develop function desired to make it into first shipment, but it could, if necessary, be included in an early post-FCS release. Major functionality for each feature block is tracked in Kanban-like fashion, illustrated by the boxes at the bottom of the page. The image at right visualizes sprints to develop a part of the software functionality. It shows a development sequence to develop a first increment of functionality, working path first, to maximize usability of prototypes across all participating organizations. For each of several following functional increments, the image shows aggregation of function and development and integration sequences. Finally, the image shows key dependencies among sprints, including dependencies on hardware availability from the green bars at top. The plan visualized by images of these kinds supports several desirable effects. It portrays a nominal sprint sequence for several functional increments. It helps identification, recording, communication, management, and tracking of dependencies. It communicates critical dates on deliverables. It can be used to help design and manage changes. It visualizes where parallelism can be used to optimize net schedule duration. It helps planning of parallelism and of critical resource availability. Its net effect helps understanding, planning, communication, and tracking paths to develop software that scales across multiple organizations developing a complex system effort. The image at left visualizes development and deployment of testware for hardware. This kind of activity is strongly cross-functional, requiring good communication in planning and in execution, including development of tests at left for manufacturing development and compliance, and execution of preliminary and formal testing. The effect of the visualization is to plan and coordinate a strongly cross-functional effort. The image at right is a more detailed view of build and test dependencies for formal compliance testing on systems representative of units to be shipped and fitting that testing into tight FCS shipment expectations. Again, these images help understand and develop a plan with complex interactions and is again automatically linked directly with plans with detail across the organization to successfully execute such a plan. This figure illuminates a really complex part of a plan, tightly constrained by time and available material, and requiring complex material handling among globally distributed sites. This plan directly affects the FCS build and shipment plan. Once again, the purpose of the image is to develop a good plan among organizational participants, with understanding among participants as it unfolds over time. We also communicate with management and personnel outside of direct execution to provide blocking and tackling as it's needed. And of course, the visual is backed up by directly related detailed material, build, and test plans for all participating functions. A final example, a high-level view showing parallel development and test of several levels of hardware, software, and test. The image highlights parallelism and coordination of integration involved in the effort, and shows the effort from start to finish. The intent was to provide perspective of the program plan, execution, and status throughout the organization and over time. Of course, everything shown was directly connected to detailed plans at all levels of the organization and across all function. It really helps a program when people are all working in the same direction, with detailed understanding of their immediate and upcoming work, able to set their own priorities and to act independently on details, and provide technical work plus blocking and tackling as needed in ways that are consistent with the plan for the overall program, at all levels of work, from executive through organizational management, technical, and operational work. The OPI task data sequence continues in OPI Task Data Part 2 Structured Gantt Plans. Please subscribe to this channel and like the videos.